This week on Engineering Newswire, we're reinventing the toilet, testing a hypersonic wave rider, and flying a plane inside of buildings. Microsoft founder and billionaire philanthropist Bill Gates wants to reinvent the toilet. According to the Bill and Melinda Gates Foundation, which hosted a Reinventing the Toilet fair on August 14th and 15th, 4 out of every 10 people around the globe don't have the ability to lay or pray to the porcelain god. That adds up to 2.6 billion people looking to improvise using anything they can find. And as the foundation says, that adds up to quite a pile of problems. The foundation has committed $370 million to the Water, Sanitation, and Hygiene Initiative, which hoped to bring the toilet into the 21st century and turn Mr. Hanky into everything from fuel and fertilizer to fresh water. Engineers have flocked to the fecal problem, and with ideas ranging everything from a Swiss system that diverts urine and recovers water from flushing, to the first-place prototype designed by the California Institute of Technology that is not only solar-powered but also generates hydrogen and electricity. A self-contained system from the researchers at Stanford University and the Climate Foundation pyrolyzes human waste into biological charcoal. But I assure you that when you're invited to a barbecue on the PD&D campus, that sweet smell by the grill is mesquite. In some cases, you just can't accept any substitutes.
The Wave Rider X-51A test was a failure. The vehicle was launched successfully from a B-52 bomber over Point Mugu Naval Air Warfare Center. But shortly after launch, a fault was identified with one of the cruiser control fins. And then shortly after that, the craft separated from the rocket booster, however lost control. The test is a blow to the Wave Rider program, but also a setback for the development of hypersonic flight, since the control subsystem responsible for the failure had proven reliable in past flights. According to the release, program officials will now be in the process of working through a rigorous evaluation to determine the exact cause of all factors at play. One of the 4 X-51A vehicles left, but there's no official word as to whether it will actually fly. A roundtable will be scheduled in 2 weeks after officials have analyzed data from the failed test.
For decades, academic and industry researchers have been working on control algorithms for autonomous helicopters. Progress has really been amped recently, and now MIT's Robust Robotics group is developing autonomous controlled algorithms for the indoor flight of GPS-denied airplanes. Flying an autonomous helicopter in an entire environment is hard enough, but an airplane is a whole nother story. It's going much faster, and it can't do arbitrary motions. MIT researchers built their own plane from scratch, and it has unusually short and broad wings, which allow for it to fly at relatively low speeds and make tight turns, but still afford it the cargo capacity to carry the electronics to run the researchers' algorithms. The plane has to determine where it is on a digital map in real time, using data from a laser rangefinder and inertial sensors, accelerometers, and gyroscopes that it carries on board. The MIT researchers' next step will be to develop algorithms that can build a map of the plane's environment on the fly. The addition of visual information to the rangefinder's measurements and the inertial data could make the problem even more tractable.
Pivot had also made an appearance at the EAA AirVenture Air Show, promoting its brand new shades. The recordable 1080p eyewear features 3 resolution settings as well as 3 different focus settings and an 8-megapixel digital still frame camera that records on an 8 gigabytes of internal memory. While I think these are some spiffy shades, I'm concerned about the opportunities they provide to sketchy characters.
NASA's Mars rover Curiosity spent its first weekend on the red planet under the knife. The brain transplants, or NASA's quirky way of describing Curiosity's software, better enables the rover for future tasks. The upgrade basically works with the rover's robotic arm, as Curiosity carries 10 different instruments and has a total mass 15 times larger than the science payloads on NASA's Spirit and Opportunity. The toolkit includes a laser firing instrument that checks the elemental composition of the rocks and a drill scoop combination used to gather soil and samples of rock interiors. It also has the ability to sieve and parcel out the samples into the rover's analytical lab instruments. Each instrument is the first of its kind on Mars. Obviously, it's the first time, whatever. A key capability of the new version is image processing, which helps check for obstacles on the landscape. It will allow Curiosity to have longer drives by giving the rover more autonomy to identify and avoid potential hazards. If only the same software could be installed on my Toyota Yaris.
Meanwhile, about 150 million miles away, on Earth, a test model planetary lander crashed and burned at Kennedy Space Center in Florida, just seconds after liftoff. NASA suspects a mechanical device that was part of its GPS navigation system caused the fault. The experimental lander already had 19 flights at Johnson Space Center in Houston, where it was designed and made, and one more in Florida, but it was always tethered to a crane in those flights. The lander was built mostly with low-cost, off-the-shelf materials. It was an attempt by NASA to use cheaper, more readily available, and environmentally friendly rocket fuel. The space agency was considering it as a potential lander for places like the moon or an asteroid, figuring it would carry a human-like robot or small rover. So far, NASA has spent $7 million on the Morpheus program, but that includes parts of a still-to-be-built second lander. Morpheus is a prototype for a cheap, environmentally friendly planet lander, though the space agency hasn't committed to using the lander in any specific flight. The methane and liquid oxygen powdered lander was a total loss, but nobody was hurt.
For PD&D TV, I'm David Manti, and this has been your Engineering Newswire.